as we discuss the derivative more and more, we're going to see that we're going to be quite interested in determining when the derivative of a function is equal to 0. So let's get a start on that now with example number 5. Okay, we have g of x is equal to that polynomial right there, x cubed minus 12x squared plus 45x plus 3. And we're interested in finding what values of x cause the derivative to be equal to 0. So again, we're not plugging 0 into the derivative, we're setting the derivative equal to 0 and determining what x values make that statement true. But before we can do any of that, we need to actually get the derivative. So let's do that using our 4 basic rules. So we want g prime of x, okay, and I certainly encourage you to pause the video at this point and actually find the derivative of this function. See if you can do that without any help from me, but you have this available as well. So x cubed derives to 3x squared. 12x squared, well, the 12 stays down, and then x squared derives to 2x. 12 times 2 is 24, so we have 24x for the derivative of 12x squared. And again, we kept the minus sign. Plus, and then we take the derivative of 45x. We know by now that whenever we derive anything where it's a coefficient times x, the derivative will just be the coefficient. So plus 45. Finally, we have the plus 3. That's a constant. Constants derive to 0. So here's our derivative. Okay, we're interested, when does this derivative equal 0? Okay, so we just did the calculus step to the problem, and now we have to do the algebra step. The big reason why you took 2 years of algebra is to help us get through problems like this. Okay, how do we solve this? Well, we have a quadratic that's equal to 0. We can go with the quadratic formula. We can go with a whole bunch of ways to get this. What we cannot do is subtract 45 from both sides and then factor out an x. That doesn't work. We don't want to go that route. What we do like to do when we have quadratics is look for the product of two binomials. Now initially though, it might be easier if we look at these 3 terms, say, well, wait a minute, all 3 terms have a common factor, don't they, of 3? Let's factor that 3 out. So we have 3, and then we're left with x squared minus 8x plus 15 is equal to 0. Okay? Now it's a little bit easier to factor this quadratic. We have a quadratic where the leading coefficient is 1, which means that ideally we can do a quick factorization if we can find 2 numbers which multiply to our constant term, 15, and add up to our linear coefficient, which is negative 8. What are 2 numbers that multiply to 15 and add to negative 8? Exactly, negative 3 and negative 5. So what we have here is 3, and then we have x minus 3 and x minus 5. All right, that's our basic factorization from algebra and a little bit of algebra 2 there that we've been doing for years and years and years. And that's equal to 0. Okay? Now that's good for us because we have the zero product law. The zero product law says that if we have a product and that product is equal to 0, it means that one of these 3, at least, needs to be equal to 0. So we just got to figure out what values of x make this true. Can 3 ever be equal to 0? No, it can't. So there's no answer that's coming from this 3 right here. It's just useless. It's hanging out front. But now we go to our second term. We have x minus 3 is equal to 0. What value of x makes that statement true? Exactly, 3. So that's one of our values of x that's going to be in our answer. X can be 3. Okay. Now we have our third part, x minus 5. When is x minus 5 equal to 0? For what value of x? 5. There's our second answer. So when x is 3 or x is 5, that is when our derivative will be equal to 0.